start recording. So we have some special forms, and we talk about the difference of two squares and the perfect squares, and did some examples before, and then we talk about the sum and the difference of cubes. Okay, so we got those kind of formulas, and you're not required to memorize everything at one time, but just know you can factor them using the formulas. So let's just try to factor the difference of two cubes, x cubed minus 27. First, you can rewrite the expression as x cubed minus 3 cubed. Remember, 27 can be rewritten as 3 cubed. So that becomes a difference of 2 cubes, and then you just use the formula of u cubed minus v cubed equals u minus v times u squared plus ue plus v squared. Okay, so u equal to x and v equal to 3. Then you're going to get x minus 3 times x squared plus x times 3 plus 3 squared. And then, just rewrite in the standard form. So we got x minus 3 times x squared plus 3x plus 9. Okay, if you square 3, you get 9. So that's the difference of two cubes. So basically, use the formulas. All right, and then we can also factor sum of two cubes. For example, we have x cubed plus 216 to factor, and you can, write 216 as 6 cubed. If you multiply 6 by itself 3 times, you're going to get 216. 6 times 6 is 36, and you multiply 36 by 6, you're going to get 216. So then you can use the formula for sum of two cubes. If you let x equal to 6 and v equal to x, u equal to x and v equal to 6, and then you use the formula of u cubed plus v cubed equals u plus v times u squared minus uv plus v squared. So you're going to get x plus 6 times x squared times minus x times 6 plus 6 squared. And then just simplify it. 6 squared is 36. So you get x plus 6 times x squared minus 6x plus 36. All right. Okay. So let's do another example. This time we got 5y cubed plus 135. So the very first thing to do for any factoring problems is to factor a common number or expression from all the terms. So in this problem, we can obviously factor 5 from the two terms. So we get 5 times y cubed plus 27. You can factor 135 as 5 times 27. And then again, you can rewrite 27 as 3 cubes. And then you use the formula again for the sum of two cubes. Use u cubed per cube equals u plus v times u squared minus uv plus v squared. So then the whole thing just becomes 5 times y cubed. Yeah, okay. So the whole thing 5y cubed plus 135 becomes 5 times y cubed plus 3 cubes. And then if you rewrite as u cubed plus v cubed, then that becomes 5 times u plus v times u minus uv, u squared minus uv plus v squared. And then plug in u for y for u, and the 3 for v. So we're going to get 5 times y plus 3 times y squared minus y times 3 plus 3 squared. And 3 squared is 9. So at the end, you're going to get 5 times y plus 3 times y squared minus 3y plus 9. One thing to remember is you should not, drop the 5 when you factor it in the first stage or step. Any questions for this problem? I'm going to post this slides for this section when we're done today. Definitely. I didn't post it because we didn't finish it. All right. But as you know, we already have the video recorded, so you can also watch the video when it's not completed. All right. If there's no question, then let's go to the next page. Trinomials with binomial factors. Okay, sometimes you can factor trinomial, so that means a polynomial with 3 terms. Okay, that's trinomial. You can factor it out easily. In this example, we want to factor x squared minus 7x plus 12. So how do you do that? You try to find the two numbers. If you add them, you get -7. If you multiply them, you get 12. And these two numbers can be easily figured out to be -3 and -4. If you add -3 with -4, you got -7. And if you multiply -3 and -4, you get +12. So then you just write down the answer as x minus 3 and x minus 4. And that's the way to factor this trinomial. All right, when the leading coefficient, the coefficient x squared is 1, that's always the way to factor it, to find those two numbers. All right, so that's pretty simple. Oh, okay, I don't know why I got this messed up a little bit, but this is called factoring by grouping. Okay, factoring by grouping. So you can use the factoring by grouping to factor, the polynomial with 4 terms. What you do is you just group 2 terms and group the other 2 terms and then factor them separately. Okay, so in this problem we got x cubed minus 2x squared minus 3x plus 6. So why don't we just group x cubed and the negative 2x squared and the group negative 3x with 6. And then you just factor x squared from the first group. So you get x squared times x minus 2. And then you factor -3 from the second group. So that becomes -3 times x minus 2. Now you can see, these two groups have the same factor of x minus 2 that you can pull out. If you do that, then you're left with x squared and -3. So the final answer will be x minus 2 times x squared minus 3. All right? Okay. So this again, examples of factoring by grouping. Sometimes the problems can get a little more complicated when the leading coefficient of a trinomial is not 1. So there are 3 examples in here. Each of them has a leading coefficient not equal to 1. So in the first problem, we got 2x squared. So that's 2. And in the second problem, we got the 12x squared. And in the third problem, we got 3x squared. So in all of those problems, the leading coefficient, the coefficient for x squared is not 1. In that case, if you want to use the factoring method, then use grouping, all right? But this time it has to be done in 3 steps. It will be a little different from the previous problems. The 3 steps are as follows. Okay, first, you multiply the leading coefficient with the constant term. So in the first example, we got 2x squared minus 5x plus 3. So the leading coefficient is 2, and the constant term is 3. So you multiply them, you got 2 times 3 equal to 6. And then now you need to find the 2 numbers. So that if you multiply those 2 numbers, you get 6. Okay? And if you add them, you get -5, which is the coefficient in the midterm, the linear term. Okay? So we need to find 2 numbers. When we multiply them, we get 6, and when we add them, we get -5. So those 2 numbers are -2 and -3. Okay, and then you use the 2 numbers from step 2 to split the -5x in the problem into 2. negative 2x and negative 3x. And then we got 2x squared minus 2x minus 3x plus 3. Okay, that's why you need to find those two numbers in step 2, and they are used in splitting the middle term. And then you just group the first term, two terms, and group the second two terms, and factor each term separately. So from the first group, we can factor 2x, and we get x minus 1. And in the second term, we can factor negative 3, and we get x minus 1 also. And if you look at those two groups, they have a common factor of x minus 1 that can be taken out, and then what is left is just 2x minus 3. So the final answer is x minus 1 times 2x minus 3. So that's a different method, all right? 3 steps. Okay, any questions? Okay, let's do some more examples. This time we need to do 12x squared plus 7x plus 1. Let's just do it in 3 steps, factoring by grouping. Okay, so again, the first step is to multiply the leading coefficient 12 with the last term 1. So you get the 12 times 1 equals 12, and then you need to find the two numbers. If you multiply them, you get 12. If you add them, you get 7. The coefficient for the linear term. Okay, so these two numbers obviously are 3 and 4. If you multiply them, you get 12. If you add them, you get 7. And then you use those two numbers to split 7x into 3 and 4x. So we can rewrite the problem as 12x squared plus 3x plus 4x plus 1. And we group the first two terms and the last two terms, and factor each group. So you can factor 3x from the first group to get 4x plus 1, and you can factor 4x plus 1, with 1. Basically, you don't factor anything but 1. So now we have 4x plus 1 in common in the two groups that you can take it out from the whole problem. So now it becomes 3x plus 1 at the end. So what is left is 1. If you factor out the 4x plus 1 from 4x plus 1, it becomes 1. So so the final answer is just plus 1 times 3x plus 1. All right? And then let's do another one for this method. Let's do steps as 3 steps as before. So the first steps, multiply the first number 2 by the last number, negative 12. So we got the negative 24, isn't it? And then we need to find the two numbers. If you multiply them, you get 24. If you add them, you get positive 5. The coefficient for the middle term. And those two numbers are 8 and negative 3. If you multiply 8 and negative 3, you get negative 24. If you add 8 with negative 3, you get positive 5. So then you can split negative 5x into 8x and negative 3x using the two numbers in step 2. And then group the first two terms, less than the second, the last two terms. So we got 2x squared plus 8x plus negative 3x minus 12, and then factor each group. So you can factor 2x from the first group, you get x plus 4, and you can factor negative 3 from the second group, you get x plus 4 also. So now we got the common factor of x plus 4 in these two groups that we can take it out. And if we do that, what is left will be 2x minus 3. So the final answer is x plus 4 times 2x minus 3. Any questions for this method? Okay, if we don't have any more questions, then we're going to move to the next section, P5. Okay, let's see, P5. Let me get a 5 first. is it P5, P4? Okay. 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 Rational expressions. So we're talking about a different topic now. Rational expressions is okay. Is or division of two polynomials. All right. But let's talk about in general the domain of any algebraic expression. Okay. So so when we talk about domain, what does it mean? What does it mean in this case? It means when you have a algebraic expression or a function, all the values of x that works for the function or the expression. All right. So for example, the domain of the polynomial 2x cubed plus 3x plus 4 is all real numbers. Some people I heard they say that the domain is x. That is not right. You have to tell exactly what numbers are for any specific algebraic expression. So for this polynomial, 2x cubed plus 3x plus 4, the domain is all real numbers. It has to be specific because every time when you plug in a number for x in this expression, it always gives you a finite number. So it always makes sense to plug in any real number. So that's why the domain is real numbers, all real numbers. Now, in the second example, we need to find the domain of the radical expression, square root of x minus 2. In order for this expression to make sense, then we need to require that x minus 2 is positive or 0. It has to be greater than or equal to 0 inside the radical. So that means the domain is all real numbers greater than or equal to 2 if you solve this inequality. So that when you subtract the 2 from x, you get the positive number 0. All right. So like 3, x equals 3, then 3 minus 2 is 1. You take the square root of 1, you get 1. Or x equal to 4. 4 minus 2, you get 2. You take square root, you get the real number. But you cannot plug in 1 for x. If you plug in 1, you get the 1 minus 2, you get negative 1. You cannot take the square root of negative 1, you get the real number. You don't get the real number here. So that's not in the domain. So the domain is for all the values of x that works for the expression. So all the x values have to be greater than or equal to 2 in order to make the number under the radical to be positive or 0, right? So that's example 2. Example 3, we got a rational expression x plus 2 over x minus 3. So this time, what we need to look at is the denominator, because we cannot divide by 0. So as long as x is not equal to 3, then we can always do the division and get the final number. So it makes sense when x is not equal to 3. And obviously, if you plug in 3 is 0. So that will not be in the domain. 3 will not be in the domain for x. So the domain of this expression of x plus 2 over x minus 3 is all real numbers except 3. Okay, remember, you're trying to find all the numbers for x that work for the expression. And the only number that doesn't work for this expression is x 3, right? So make sure you got the concept of the domain precisely. Okay, and then one of the things that we always do is simplifying rational expressions in simplest form. Okay, so if we got as I say, the rational expression is the division of two polynomials, and we already talked about how to factor polynomials. So if you can factor the top and the bottom and then cancel the common factors, then you can simplify the rational expression. Like in this example, we get 4x plus 12 on the top and the x squared minus 3x minus 10 at the bottom. So we can obviously factor 4 from the top to get 4 times x plus 3. And we can also factor the bottom trinomial by x plus 3 times x minus 6. Remember, 3 plus negative 6 is negative 3, and 3 times negative 6 is negative 18. And then we get x plus 3 in common that we canceled. So at the end, you just get a 4 over x minus 6, isn't it? You can always simplify rational expressions in this way by factoring both the top and the bottom. So in the next example, we got 12 plus x minus x squared over 2x squared minus 9x plus 4. So on the top, in the numerator, we got negative x squared. That's the leading term has a negative exponent, and we usually factor out a negative sign from the top from each term. So that we're going to get the x squared minus x minus 12. All right, that will be a little easier for us to factor. Okay, and at the bottom we got another trinomial that we can use factoring by grouping, as we just discussed. You multiply 2 by 4, 8, and then you find two numbers with the product 8 and the sum of negative 9. And then you split the term of negative 9x, with those two numbers, and then factor by group. And at the end, you're going to get the x minus 4 times 2x minus 1 if you factor in this way at the bottom. And at the top, x squared minus x minus 12 is simply factored as x minus 4 and x plus 3. If you multiply negative 4 by 3, you get negative 12. And if you add negative 4 by 3, you get negative 1. Okay, so then we get the common factor of x minus 4 on the top and at the bottom that can be cancelled. So the final answer will be negative x plus 3 over 2x minus 1. All right? Okay, sometimes you get two or more rational expressions to multiply to each other, but then you can always simplify the results by canceling common factors as before. So in this problem, we got 15x squared plus 5x over x cubed minus 3x squared minus 18x times x squared minus 2x minus 15 over 3x squared minus 8x minus 3. Just factor each part separately and then try to cancel the common factors from the top and at the bottom. Okay, so 15x squared plus 5x, obviously you can factor 5 on the x, you get 3x plus 1. And x cubed minus 3x squared minus 18x, you can start from factoring x from all the terms to get x squared minus 3x minus 18. And then at the same time, you can factor the second expression on the top of x squared minus 2x minus 15 by x minus 5 and x plus 3. You multiply negative 5 by 3, you get negative 15, and you add negative 5 and 3, you get negative 2. And then you can factor 3x squared minus 8x minus 3 by group like we did before in 3 steps again. So if you continue with this process, in the first rational expression in the denominator, x squared minus 3x minus 18, that can be further factored as x minus 6 and x plus 3. Negative 6 plus 3, you get negative, and negative
Hey,
6.
can you take roll? I got enough class.
Okay, time 3. Okay, I'll be finished really quick. And multiply negative 3 and 3 get negative 18. And then you can factor 3x squared minus 8x minus 3 by using factoring by grouping. You get 3x plus 1 and x minus 3. And then you can see in a lot of cancellation occurs. 3x plus 1 both appear on the top and at the bottom that be cancelled. Also, x plus 3 can be cancelled. They appear both on top and at the bottom. And also x in the first expression that be also cancelled. So after those cancellations, what is left is just 5 times x minus 5 on the top and x minus 6 times x minus 3 at the bottom. So I guess I'm going to stop here and take the roll. Let me just stop the recording.